Hey everyone, and welcome. Today, we are talking about something we've all seen a million times, the rainbow. But what if I told you that the classic arc shape we all know and love, well, that's only half the story. Let's get into the rainbow's real secret shape.
I mean, it seems like the easiest question ever, right? You look up in the sky, and there it is. It's an arc. A big, beautiful, colorful arc. But that arc, it's actually just a clue. It's the tip of the iceberg of a much larger, more perfect shape that's literally hiding in plain sight. And there you have it. That's the big secret we're diving into. The rainbow is a full circle. So the real question isn't what shape it is. It's why on earth do we only ever get to see part of it? And to answer that, we have to figure out what a rainbow actually is.
Okay, so to solve the mystery of the missing half of our circle, we need to get a little personal. Because it turns out, the rainbow you see, it isn't really out there in the way you think it is.
This is absolutely the key. You can't touch a rainbow. You can't fly to the end of it to find a pot of gold, because it's not a thing. It's an optical effect. Think of it like a reflection in a puddle. It only exists from your specific point of view, created by this perfect geometric lineup between the sun behind you, the raindrops in front of you, and your own two eyes.
And get this has a wild implication. If you're standing right next to your friend looking at the same rainbow, you're actually seeing two completely different rainbows. The light from one specific set of raindrops is entering your eyes, and light from a totally different set of raindrops is entering theirs. That's why if you walk to the left, your rainbow moves with you. It's always, always centered on you.
So, we've established a rainbow is a personal experience. But how does that experience get its shape? Well, the first clue is hiding inside one single tiny drop of water. You see, every single raindrop in the sky is acting like a tiny little prism. When a ray of sunlight hits a drop, first it enters and bends. That's called refraction. Then it bounces off the inside back of the drop like a mirror. And finally, it exits the drop, bending one more time on its way out. It's that double bending action that splits the white sunlight into that beautiful spectrum of colors.
Now that journey of light inside one drop is pretty cool. But the real magic, that's what happens when you have millions and millions of these little prisms, all doing the exact same thing at the exact same time.
This is the magic number, 42 degrees. Because of the physics of how light moves through water, the colored light that makes up a rainbow always exits the raindrop at this very specific angle, about 42 degrees. And this isn't random. It's not a guess. It's a hard and fast rule of optics.
So try to picture this. You've got millions of raindrops out there, all sending colored light flying in every direction. But you only see the light from the drops that are at that perfect 42-degree angle from your line of sight. And if you trace out all the possible points in the sky that fit that 42-degree angle relative to you, what shape do you get? You get a perfect cone of light. And you're standing at the very tip, with the rainbow being the giant circular base of that cone.
So what's at the dead center of that circle? It's a spot in the sky called the anti-solar point, which is a fancy way of saying the spot exactly opposite the sun. But here's an easy way to find it. Just look for the shadow of your own head. The rainbow is a perfect circle centered directly on your shadow. I mean, how cool is that? It really shows you just how personal this whole phenomenon is.
Okay, so the physics is crystal clear. The rainbow is a 42-degree circle of light, which brings us right back to the big question. If it's a full circle, why in the world do we only ever see an arc?
And the answer, believe it or not, is incredibly simple. The culprit is the ground. The very horizon that we stand on is what slices that perfect circle in half, leaving us with just the top part.
The ground messes things up in two ways. First, the obvious one. The Earth physically blocks your view. You just can't see the raindrops that are hanging in the air below the horizon line. But second, and maybe more importantly, there just aren't any raindrops in the ground beneath your feet. The space where the rest of the rainbow should be forming is full of dirt and rock, not misty air.
And the position of the sun plays a huge role here too. Think about it. When the sun is low on the horizon, like in the late afternoon, the anti-solar point, the center of the rainbow, is high in the sky. This lifts that whole circle up so we get to see a big, beautiful arc. But when the sun is high overhead, the center of the rainbow gets pushed way down, hiding most of it below the horizon.
In fact, there is a specific cutoff. If the sun climbs more than 42 degrees up in the sky, that's it. The entire rainbow circle dips below your horizon. It's still there, technically, but it's completely hidden by the ground.
And that's exactly why you almost never see a rainbow in the middle of a summer day. So the ground is the problem. It's the obstacle. But what if we could get rid of the ground? Or at least, what if we could change our perspective on it? Well, it turns out you can. And when you do, the full circle finally shows itself. The trick is you have to get to a place where you can see water droplets below your horizon. So yeah, this means getting up high. Think about being in an airplane looking down on a cloud, or standing on the edge of a huge cliff, or even just on top of a skyscraper. Anywhere that gives you a view of misty air beneath your feet gives you a chance to see the whole shebang. And listen, this isn't just a theory. This is a documented, observable reality. Pilots see and take pictures of complete 360-degree circular rainbows all the time. From way up there, high above the clouds, the ground is no longer an obstacle, and the rainbow's true, perfect, circular shape is finally revealed.
So here's the bottom line. The arc that we all know and love, it isn't really the rainbow's true form. It's just the slice of the rainbow that our position on the ground allows us to see. It's a gorgeous but ultimately incomplete picture.
I just love this final thought. The rest of the rainbow, the missing half, it isn't actually missing. It's not a flaw. It's always there, perfectly formed in the geometry of light and water, just hidden from our usual point of view. It's a hidden circle waiting for us to see it from a different perspective. And that really makes you think, doesn't it? If something as familiar as a rainbow has this secret, perfect shape that's hidden from us most of the time, what other incredible things are out there just waiting for us to change our point of view? Thanks so much for joining me.